Oh boy, I'm really struggling with this. I'm making this video to sort of rescind some advice or recommendations that I made to Odysseus about a problem he's having with his lights and horn. I screwed up the original recommendations because I had some misconceptions about how the system works. I stumbled across something that just makes a lot of the prior testing that I'd recommended, bogus. The horn has two wires. One red, black and red. This is a hot wire. Okay, it's hot all the time the key is on. The other, black and blue, which is the ground wire. It ties into the horn button, and the horn button connects this black and blue wire to the white and black, or black and white ground bus. Grounds the horn. Juice flows from the black and red wire through the horn, through the black and blue wire, through the button to ground. The horn honks. So while I was messing around with the thing, I had inadvertently hooked my meter up to the ground wire, the black and blue wire. You can see some stray voltage on there right now. And when I turned the key on and I pressed the horn button, I get 12 volts. 12 volts in the ground bus. It's not right. So this recommendation to hook up the test meter to the negative terminal of the battery and disconnect the negative cable, and then use the red lead or the positive lead on the meter to check for voltage at various points in the system, is bogus. It doesn't work right. You get juice feeding back through the ground bus into all sorts of components, and I'm finding 12 volts all over the place where I shouldn't have it. So I'm going to rescind that recommendation, and let's do a different test with the battery hooked up. Okay, so I'm going to start by reconnecting the battery. Just bear with me. I'll do this as fast as I can. Okay, battery's hooked up. We'll hook the meter back up. Okay, let's see what we have now. We're still hooked up to the black and blue ground cable on the battery, which ties to the button to the black and white ground bus. I turn the switch on, no voltage. I press the horn button. It changes a little with some stray voltage, but now I'm not picking up at 12.5 volts or so. So let's go through the test regimen again. Okay, only do it the right way with the battery and the negative battery cable hooked up. Okay, so I'm going to start by hooking a battery charger up to this jalopy because this battery has really had it. Pretty much used it up doing all these tests. Okay. So now we've got a battery charger on the thing. Let's get the meter and ring the system out from the main switch, the ignition switch, up through the multi-connectors under the tank and into the switch assembly is the right-hand handlebar switch assembly and the left-hand handlebar switch assembly. Hopefully you can see this meter right now. Okay, the switch gets hotted up by the red and black wire. You can see I got battery charger's getting it on, 14.9 volts there. Okay, and the yellow wire, which is the hot bus, not yellow, orange wire, which is the hot bus, we've got nothing. Okay, when I turn the key on, the switch on, Now we got about 13.6 volts going into the orange bus that distributes power throughout the motorcycle. Turn the switch back off. Let's move around to the other side so we can look at the right hand multi-connector under the fuel tank. Hopefully you can see that pretty good. Okay. So I'll turn the switch back on. And we're going to check to make sure that we're getting juice to the, the orange bus up here. 14 volts. So now, if we touch the meter to the yellow and white wire, which is the juice coming out of the handlebar switch, we still have 14 volts. That tells you that the connectors and the right hand switch assembly, the auxiliary switch and the starter button that provides power to the lights and horn, that tells you that all of that is okay. You're getting full voltage coming out of there. Okay? So now, if I press the starter button, you can see the voltage drops down to almost nothing. That's because it's opening the contacts that provide juice to the lights and horn. If I release the starter button, we're back to 12.5 volts or so. Now we come over to the left-hand multi-connector on this side of the bike. Let's see if we can reposition the camera so you can see that a little bit better. Right? We want to know that we're getting juice from the right-hand multi-connector over to the left-hand multi-connector. So we test the yellow and white wire here. 14.6 volts, so good. That means we got power going from this left-hand multi-connector, and hopefully the connection is good. It goes up to the left-hand handlebar switch assembly and provides power to the dimmer switch and to the horn. Okay, so now we come on this side and we want to see if those switches are working okay. We check to see if we have power at the black and red wire here. Okay, black and red wire, 14 volts, if I can get it in there any good. Okay, so we're getting power to the horn. That's good. And that also tells you that you should be getting power to the lights, because they both tie into the same black and red wire. 14.66 volts. Now if I press the starter button, it behaves just like it ought to. The voltage drops to almost nothing. Release the starter button, back to a little over 12 volts. You can see that battery really craps out fast. Press the button, drops to nothing. That's because the auxiliary contacts and the starter button switch are opening up. And when I release the starter button, they're normally closed when the button is released. You get full voltage to the horn and the lights. Okay? And we already tested this ground to make sure that it's not hotted up. So there's the ground. And when I press the horn button, it changes a little with stray voltage, but you're not getting battery voltage there. Okay, so that's looking pretty good. Hopefully I didn't screw everybody up too much with my bogus test. And hopefully this helps some.